Okay, this is the EOC journal number 9, I guess. So I'm just going to write that up here. EOC journal number 9. And the topic for this one is linear function scenarios. That's the best name I can come up with. Basically here, what you're trying to figure out, we're looking at this number 16 from our mock EOC, and what we're trying to figure out is which of these situations best represents a linear relationship. Meaning, which of these situations can you write into y equals mx plus b. Alright, so let's take a look. I've given you guys some advice about not looking at the answer choices until after you solve the problem, and unfortunately in this scenario, this is one of the few problems that you would have to look at the answer choices in order to find your actual answer. Okay, so which of these best represents a linear relationship? You could do this a couple different ways. You could try to write the equation like we said here, or you can another thing you could do is you could try to draw a graph. Draw a graph. Okay, but again, when you draw this graph, you need to know the x-axis, that's the independent, and you need to know what the y-axis represents. You can't just draw a picture of a graph. You can't just say, oh, well, here it is, so it's linear, it's got to be right. You actually have to know what each one of these is. What is this? And what is this? All right, so let's take a look at our scenarios. We've got to start with A, and we're going to go through all of them. And like I was telling fourth period today, you don't want to mark any of these out unless you have proven it to be wrong. So I'm going to show you that today as well. All right, so the first one, the height of a female throughout her life as a function of age. Okay, so let's take a look. If I draw a table for this, I'm just going to make a mini table over here. What would be here independent? Would it be height or age? Well, it says as a function of, okay, so height as a function of age. So you could also say that height depends on age. So then that means that age is independent, so age would go here, and height is dependent, so height labeled by H would go there. So as they get older, it's going to go this way. Are they going to get taller or shorter? Well, ideally, you can get taller, 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 right? Now, some metaphysical deals or biological situations, when a wife or a lady or a man gets to a certain height, when they get older, they actually start to shrink a little bit. Not all the way back down to nothing, obviously, but they'll shrink a little bit. So a graph may look like this. That's plausible. But then again, you could have a graph that looks like this. And it shrinks a little bit and then levels out. So as of right now, though, I like this answer as a linear function. So we'll start with A. Actually, let me take that back. I don't want to erase it. I can't prove it necessarily to be wrong. A seems good. Let me see if there's a better answer choice. How about the height of a football after it's kicked as a function of time? Okay, well, let's take a look. Let's erase this graph over here. We've already determined that this graph, this probably looks like this. Okay, again, maybe technically it could go like this and down a little bit, but as of right now we think it's linear. So let's look at a graph then for the height of a football over a given time. Okay, so again, height is a function of time. So again, just like the last one, we could say height depends on time. So time is here. And again, height here. Well, when you pick up the football, let's say the football starts on the ground. You pick it up, you kick the ball into the air, over time, that ball doesn't keep going up. It eventually has to, because of gravity and Newton, has to come back down until it lands on the ground again, assuming nobody touches it or catches it. So, with that being said, is this a line or linear? It is not. In fact, this would be quadratic with a negative a, if you remember quadratics well. So I have now proven that to be wrong, so now I'm going to mark this one out because I know it is not b, because I've actually proven that wrong. Okay? Let's look at our next one. I'm going to go ahead and erase this now as well. It says the total cost for milk based on the number of gallons purchased from a store. Okay, the total cost per milk. So again, let's try to draw a graph of this situation. So the total cost of milk based on the number of gallons purchased from a store. So here's the total cost of milk is dependent. And then the total purchased from a store, so the number of gallons. So this is the gallons. Depends on the number of gallons. So the cost of the milk. So cost of milk and number of gallons. Okay? So let me ask you this. When you go to the store, if you buy more milk, is it going to, the price going to increase, decrease, or change radically, or is it going to stay the same? Well, if I buy 1 gallon of milk, it is cheaper than buying 2. So if I buy 1 gallon of milk, I might pay this amount. Okay? If I buy 2 gallons, I may pay this amount. If I buy 3 gallons, I may pay this amount. Okay? 4 gallons, this amount. 5 gallons, this amount. 6 gallons, this amount. One of the things you need to note on this, what makes this truly linear, is the fact that each gallon costs the same, right? Most times, unless there's some kind of special store, most times I'm going to buy 1 gallon of milk, it'll cost me $3. 2 gallons is $6. 3 gallons is $9. It's going up by $3 each time, so it's a consistent change. That consistent change is your slope. Okay? That slope then creates a linear. So now, this now has become our better answer. Let's go back and talk about A here in just a second. So let's go ahead and look at the last one. It says the volume of a balloon. So we do say this goes up like this. So D says the volume of a balloon based on the radius of the balloon. Okay, now, what is the volume of a balloon? This is what makes it a little more complicated. Okay, so now you're talking about the volume of a sphere or an unusually shaped size. Is the volume only dependent on the radius? Or is there more to it? Okay, so if it was only dependent on the radius, then as the radius increases, the volume is going to increase. Which that is going to be true, but here's the thing. The volume of a balloon, and you can find this on your tax chart on your star chart on star day, is actually volume equals pi. No, excuse me. 4/3 pi r squared. So there's two things you need to look at here when we're dealing with the change, whether it's linear or not. One, you're dealing with an exponent, okay? And you're dealing with the square value. So chances are this square value is going to, for one, it eliminates the linear. And if you had to guess, the good guess based on that square value would mean this might be quadratic. Not to mention that you're dealing with this fraction and pi and all these other things that are involved there. There's much more than just a simple slope there. Okay, and then the fact that you're dealing with two unknown values, the volume is dependent on the radius. So they are independent, dependent of each other, but this volume or this radius here is squared, which would in turn create a quadratic. So then D is going to be out. So I've proven those wrong. Now let's go back for 1 second. I know this video is running a little longer than I want to, but let's go back 1 second. And let's think about this too. Let's go back to A, because we initially said A was probably a good choice. But one thing is that students do this all the time, and I'm just as guilty, and we just did it here, is we don't think about this completely logically. What I mean by that is this. Think about the graph of a female's height, or a male for that matter, okay? She may be this tall when we start measuring. Then she may have a growth spurt and come up here. Then she may stay the same for a while. Okay? Then she may grow again, but not very much. Okay? And then she may stay the same, stay the same, stay the same, stay the same, and then again, maybe when she's a little older, she'll shrink a little bit. It just happens. Okay? It happens to everybody. So, now let's look at our graph. Is that linear? Well, parts of it are linear, but overall, it's not a straight line function graph. So, with that being said, A is not the best answer anymore. C is definitely our answer. All right, again, this is EOC Journal number 9, and it's linear function scenarios. You have to figure out which one is the best scenario for linear function. All right, check out the other ones as they are posted.